Okay, in this tutorial I will show you the simulation of axial turbine engine, how to do that in SolidWorks. First of all, this is the geometry of our project. Let's see the various parts. Okay, this is basically the turbine that act as a rotor. If I just take a step backward, here you can see the number of blades. First question that arises in our mind: why I use this revolve command at the end? The reason is that when we do fluid simulation and we need to select a rotating region, so this is our rotating region. So to select this we need a solid body, so we use revolve command. And when we do, don't think that for example, we have designed this blade that doesn't count while doing simulation. They will count. What happen in SolidWorks when we do simulation, that it ignore this revolve feature and take count the it take counts the blade design structure. Okay, let's see other part, the stator part. Right. Okay, click on it. Different part. Here you can see the stator part. As you can see, I didn't use extrude command here. The reason is that because these parts are not moving, this act as a stator and stator doesn't move. So this part is simply here as simple, and I didn't use any kind of extrude command. Now let's check the assembly. Okay, this is our assembly. Now to start simulation, first of all, let's see what our requirements. Click on wizard, then click on new, then click next. Internal, check on internal, click on rotation, select local region. Local region because we are going to rotate a particular region. Then click next, then select gases. We are going to deal with air only. We are not going to use any other gas. If you want to use, you can click on it, then click on next, click next. These are the temperature parameters you want to change. If you want to change, you can change as per your requirement. Click next. Result resolution, I prefer you high, for example 7. It will give you better accuracy. And click finish. Okay, now let's start the simulation. Okay, first click on it, computational domain, and increase this domain area. A question arises: why I am increasing this domain area? The reason is that think about a box in which you put the engine. If the box is small, it can't suck the air properly. So basically, this is a domain region where it's going to suck the air. The greater the domain region, the better it can suck the air. Now, right click on rotating region, select insert rotating region. Now, don't select the body randomly, just click on selection box and then click on part 3. Sorry, click on blades. As you can see, the blade is visible. Now, set the RPM minus 22,000. Now a question is, why minus 22,000? Now, as you can see, currently this arrow is this direction, but what I want that that the arrow is move in this direction, so that the flow of air is go from this way. So click when I put minus, that then the direction will change. Now click OK. As you can see, now sorry. Now as you can see, I just click here randomly and it will change the direction. It changed the direction. Now minus 22,000 rating per second. Now then click OK. Now click on boundary condition, insert boundary conditions. Now what normally mistakes I see people do, that selecting region. Now select environment pressure. Now first simple click on it, then right click on it, select other, select phase, Remember that whenever we are going to do simulation, we need to select the inner face of the inner face, not the outer face. So don't click on the outer face. Okay, then click OK. There's another method you can use for that. Click on section view. Here you can see, then click OK. Now right click on boundary conditions, click insert boundary conditions, select environment pressure, then click OK. A question arises, why I am selecting environment pressure, not mass flow rate, etc. etc. The reason that when the blades are moved, it sucks the air from the environment pressure and release the air into the environment pressure. So we are going to select environment pressure, not any other conditions. Now click OK. Wait a minute. Sorry, I select the wrong face. Select this face. Then click OK. Now as we know, we have some goals while calculating. For example, what is the pressure difference here and here after simulation, and what are the things. Now right click on goals, select surface goals. Okay, now select the inner face of the front, then select the perimeter you want to measure. Now I want to measure total pressure average, then I click on average, then click OK. Okay, now just click on it and press F2. Change the name inlet. Now right click on goals, select insert surface goals. Now select outlet, select total pressure, then click on average. OK, press F2, type outlet. Then now the last one, equation goal. Equation goal basically what that outlet divided by inlet. Wait a minute. Outlet divided by inlet. It basically tells the pressure ratio. What is the pressure ratio? As we know that it is defined in the ratio in P2 upon P1. Then click OK. Now click on run. Solve new PC this computer. I prefer you select CPU for it will increase the solving capacity of your uh, simulation. Then click on run. Now as you can see the simulation will going on, etc, etc. So you need to wait till the simulation is done. Now while the simulation is going on, as you can see that there is a change in temperature here and here. To see different kind of graphs, click on this rainbow icon, click on it. Now select the plane on which you want to see what kind of things going on, then click on settings, then select the parameter you want to see, for example pressure. Click OK. Now here you can see the pressure. As you can see the color is same. The reason is that there is no 11 iteration is done and there is no any further enhancement is done. When the whole simulation is done, you can see there is a change in the colors and graphs plots, which basically in the initial phase, and you can't expect at initial phase at good result. When full simulation is done, you can see what kind of change is present. Then click. I'm not going to save this result because I already have done the simulation. Then click on no. Okay, now I will show you. Click activate. click on load. It will load. I already have done the simulation, so I just need to click on load so that it will load the result of the simulation. Here you can see various kinds of cut plot. Click on show. Here you can see the color difference. It basically tells us the pressure, that his pressure is higher. As you can see, 1.23 is 11. While doing simulation, as you can see, there is a transparency. You can control the transparency by clicking on model transparency, 0.5, 0.8, 0.9. You can change as per your requirement. Now, some people ask that I am a MTech student or PhD student. I need to import this data in MS Excel file. So how can I do that? Okay, to do that, first of all, front plane, click sketch, press Ctrl plus 8. Now go to XY plot. Now make okay. I didn't show you a thing. Now select a line from which you want to measure the plots. Now I have drawn a single line. Now go on flow simulation. Select XY plot. Now select the sketch. Now select all. Now go click on show. As you can see, it shows me various kinds of graph, pressure, temperature, fluid, etc., etc. So you can use them, or you can import them. Click on export to Excel. It will export all the data and graphs to an Excel file, so that you can use in your thesis, etc. Whatever you want to use. Uh, Now let's see other things. Right click on flow trajectories. Click insert. Right click on it. Select other. Select the interface. OK. Now similarly hit to the plus here. Right click on it. Select other. Okay, some mistake is happened. Wait a minute. Now right click on photo editor, insert. Make sure you select the interface. This is inlet. This is the outlet. Increase by 100. I prefer line with arrows. You can change as per your requirement. It's not necessary that you use this. Click OK. It will take some time. Now as you can see, now just go to the flow trajectories, right click on it and click on play. Maybe you can't properly visible how it is going on. Right click on upload, select hide. Now I guess now you can see, now here is the flow trajectory is going on. I hope you like this tutorial. uh, like and subscribe, because further more videos are going to coming soon, and I hope you like them. Thanks for watching.